Hello, I am going to go over the in-class assignment and also guide you very carefully on how the rubric will be designed for exam 2 regarding these questions and what exactly is on exam 2. So on exam 2 you will have all the questions on this in-class assignment plus one more question that comes from the first exam. So that'll allow you to target your studying a little bit more. Okay, let's start with this first problem. In this first problem, you're given cotangent of minus x over cosecant x plus 1 plus cosecant x over secant x minus cotangent x, and you're asked to simplify. Your first step is to change everything to sines and cosines. So when I do this, I get this ugly looking mess, where I think I walked around the room and everybody had similar things. However, what you can do right away is you can use, I just copied and pasted that to the next page. So you can use the fact that cosine at negative x is cosine x because it's an even function, and sine of negative x is minus sine of x. If we make that substitution, this top part of the fraction becomes cosine x and the bottom part becomes minus sine x. So let's drop those in. The second step is, the third step is to invert the denominators and multiply. So there's two fractions over fractions, the first term and the second term. On the first term we invert the sine x and multiply. On the second term we invert the cosine, 1 over cosine and multiply, but we have to be very careful to put up a parenthesis. You either have to combine the numerator getting common denominators and then invert and multiply, or you have to be extremely careful making sure you put parentheses around here. Out of the class, I think only one person had the parentheses. So this is a huge thing, and I have designed a rubric already for this question, this type of question, where you are guided to remember to put those parentheses. So I ask you to put those parentheses up there, even if you get the answer right, because it's an important step and we actually messed it up in class. So please remember to put those parentheses around. I have them in red there as a flag to remind you. What we see right here is in the first term the signs cancel, and I believe entirely as a class we got that correct. The second piece, I have to distribute the cosine. So the cosine x has to multiply the 1 and multiply the 1 over sine x. Cosine x times 1 is cosine x, which gives me this term right here, and the cosine x times 1 over sine x gives me the second term. And notice I haven't touched the third term at all. Now we're ready to combine things. What happens is we get negative cosine x plus cosine x, which drops out, cosine sine over sine, and the cosine x minus sine x, they drop out, and you get 0. So on the exam, this problem will not be identical, it will be different, and you may even have to use, for example, the famous identity that cosine squared plus sine squared is equal to 1. Just a heads up. Okay, the second problem I had done in class, a similar problem, but I had numerical errors the second time I did it. So I want to go through this slowly and carefully with no number errors. So the first step is to figure out which formula to use. You're going to get a formula sheet on your test. You have to choose the one that you want to use. We're going to use sine of x plus y is equal to sine x cosine y cosine x sine y, because the thing I'm looking for is sine x plus y. That's why I'm using this formula. So my job is to fill in what sine x, cosine y, cosine x, and sine y are. My given information is where I start. Sine x is 1/4 is given to me. Cosine y is minus 4/5 is given to me. So using that given information, I'm going to substitute that in. Let me back that up so you can see that animation. Sine x is 1/4, cosine y is minus 4/5. I substitute those values in right over here. Sine x is 1/4, cosine y is minus 4/5. There was an outcry yesterday because I didn't simplify right away, so I'm going to simplify right away. It doesn't matter, order doesn't matter when I simplify. That's gone, and I'm left with minus 1/5. Now, I'm almost done. I just have to get rid of this term and this term. I want to fill them in with numbers. So I need to find next cosine x and sine y. Cosine x and sine y have not been given to me. So I have to actually use this given information to figure them out. I'm going to start with finding cosine x first. Well, I'm going to use information about sine x because I'm looking for cosine x, and the other one has y's in it. So I want to use the information with an x in it. So use the fact that sine x is equal to 1/4. And use the most famous identity. You're cosine squared x, I'm sine squared x, and together we make 1. There we are. Famous identity and a Valentine's Day gift for your significant other next year. So I'm going to substitute in this sine x equals 1/4 in for sine. So I'm really taking sine x, which is 1/4, and I'm going to square it. 1/4 squared is 1/16. And now I'm going to solve for cosine squared x. Cosine squared x is 1 minus 1/16. Getting a common denominator, 16 over 16 minus 1 over 16 gives me 15 over 16. Now, I'm not after cosine squared x, I'm after cosine x. So I need to square root both sides. Square root of 15 over 16, I have to take a plus or minus because plus will give you the same answer as the minus one. And so I get a plus and minus square root of 15 over 4 because square root of 16 is 4. Now, I'm given that I'm in the second quadrant, and in the second quadrant, cosine x is less than 0. So I really don't have a plus or minus, I only have the minus. And so now I have my answer for cosine x. And notice I just dropped it in there for cosine x. Watch that animation again. I used to have cosine x here. Now I'm going to substitute it with minus 15, square root of 15 over 4, which I just found. I have now here a plus and a minus. That's just a minus. So now I have just one more thing to find, and that's the sine y. Or I'm going to find sine y in exactly the same way I found cosine x. I'm going to use the piece of information cosine y is minus 4/5. Again, I'm going to use the famous identity. If somebody actually does this on Valentine's Day next year, please let me know because I want to see how it works out. Maybe I'll try it with my husband. I don't think he'd be amused. So let's put in the cosine y as minus 4/5. We're going to square that. Squaring a negative is a positive, and I'm left with 16 over 25 plus sine squared y is equal to 1. So now I'm going to solve for sine squared y. Sine squared y is 1 minus 16 over 25, which is 25 over 25. And then when I combine the fractions, I get 9 over 25. Just like before, I'm going to solve for sine by taking the square root of both sides. So now I take the square root of both sides and I get sine y is plus or minus square root of 9 over 25. Square root of 9 is 3, square root of 25 is 5. So it works out without any square roots left in it. Now just like before, I'm in the second quadrant. The sign in the second quadrant is always positive. So in this case, I'm going to only keep the positive one and substitute that in for sine y. Watch that animation again. I got sine y is equal to 3/5. Up here I have sine y. I drop it in. Now this is not the way we usually write a formula. I think David in class said that this is not a number. He was expecting a number. This is actually a number. It's not a number you're used to, but it's a valid number. So, I mean, write it as nice as you can. For example, the 5 and the 4 multiply up to be 20, and the 3 and the square root of 15 multiply. They don't multiply at all. The numerator can't be combined, so I leave it. And notice I put the 3 out in front. Somebody was asking about that yesterday. That's because we don't want the person to be confused and think that I'm taking the 3 inside the radical. I'm not. So I make sure that there's no confusion by putting the 3 out in front. And that's the answer to this problem. It's this piece right here. Sine of x plus y is minus 5/5 minus 3 over square root of 3 square root of 15 over 20. So how will you have to give that answer? Just in this way. I will be asking you on the rubric that you have given it at least in this form. that you've made the numbers look nice, that you've combined them as far as you can, and then this is as far as you can go. If you have any questions about that, you are welcome to do the work. You have this assigned on your WebAssign. You can check with me and ask if this is an acceptable form of an answer. I'm willing to look at anything. Okay, so we're going to move on to 3 and 4 on the next few problems on the in-class assignment. I'm going to save this module, and you'll have to go to another video to get the next couple.